Assalamualaikum and good day to Dr. Razif. We are from Group 7 and now we want to present about membrane separations. So what is membrane separation? Membrane separation is a separation method that uses a thin layer of material which is called as a membrane and separate material based on their physical and chemical characteristics. The membrane functions as a semi-permeable barrier that regulates the flow rate of different molecules between two liquid phases to gas phases or liquid and gas phase. As seen in figure, a membrane separation system divides an inlet stream into two outlet streams. The outlets consist of the permeates and the retentants. The components that have flow through the membrane used by the membranes are included in the retentants. So now I will pass to Farhani to explain the advantages of membrane separations.
The advantage, membrane separation can be used a very large number of separation is required because membrane processes can separate at the molecular scale up to a scale at which particles can be seen. Membranes also have intensely high selectivity for the separation of the components. The energy requirements are usually low because membrane separation generally do not require a phase change. They usually offer a simple and easy operation and low maintenance process option as they do not have moving parts, complex control scheme and small auxiliary equipment. Lastly, membrane processes are usually better for an environment when there is a usage of relatively simple and non-harmful methods and they can recover minor but valuable constituents from mainstream with a minor energy cost.
I will proceed for the disadvantages of the membrane separation. Okay, so first, processes can be saddled with major problems of fouling of the membranes while processing some type of heat stream. Next, processing seldom produces two pure product that is one of the two streams is almost always contaminated. Next, processes often do not scale up very well to accept massive stream sizes, and last but not least, chemical incompatibilities with process solutions. This is especially in the case in typical chemical industry solutions which can contain high concentrations of various organic compounds. I will now pass this presentation to Afifa. Thank you.
I present about working principles. So this is the general schematic diagram of membrane separation process. So the feed composed of component A and B enter the upper chamber and flow into the membrane. So the retentate is the part of the feed that does not pass through the membrane and permeate is the part of the feed that pass through the membrane. So in the case of purification, both retentate and permeate can yield the desired product depending on the impurities that have to be removed. So next, this is the formula for flux through the membrane. So there are three types of membrane separation: pressure driven, concentration gradient driven, and electrical potential driven. So all these process are classified according to the driving force used in the process. So I will focus on the pressure driven membrane process. So there are four types: reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. So all these processes are differentiated by the size range of particles that are being separated, as we can see in the table.
Hi, I'm Shavika. I'll start presenting on the membrane technologies. Membrane technologies is based on the selective permeability of the membrane to allow the target substance to penetrate through the membrane, whilst unwanted substances are normally rejected by the membrane. It is generally classified into micro, ultra, nano, filtration, and reverse osmosis, and etc. However, the latest techniques are not suitable for natural products because natural products are usually larger molecules. The first method is the microfiltration, as you can compare it with the ultrafiltration. Proteins and polysaccharides cannot penetrate through the ultra, but can for the micro. But for nanofiltration, less particle can pass through the membrane because, as the name suggests, only nano-sized particle can pass through it. But compared with the reverse osmosis process, only water can pass through the membrane. A key feature of membrane separation process is the selection of membrane with appropriate rejection characteristics.
Thank you, Shavika. So now I will continue the presentation with the conclusion. So in conclusion, the use of membrane technology in separation processes has begun to emerge in the past 20 years, and its presence is expected to become widely spread in the future. The potential to use membranes exists whenever they provide the ability to remove contaminants that cannot be removed by other technologies, remove contaminants at a lower cost than the other alternatives, or require less land than competing technologies. The biggest single technical challenge with the use of membranes is the occurrence of high fouling. However, with the extensive research and development efforts on tackling the membrane fouling, membrane technology has become more promising. All in all, I would say that the future of membrane technology is indeed unlimited. Next, so here are our references. So that marks the end of our presentation. Thank you so much for watching and listening.